This section explains the Deep Q Network DQN model and code implementation. Let's first look at the Deep Q Network model overview. DQN used to train an agent to maximize rewards by learning an optimal policy. It consists of a neural network-based function approximator, an experience replay buffer, and a target network to stabilize training. Q-learning. Q-learning is a model-free value-based RL algorithm that estimates the action value function, QSA, as follows. It updates Q values using the Bellman equation as follows. Deep Q network. Traditional Q-learning fails in high-dimensional environments since 1. Large state action space requires huge memory. 2. Generalization issues cannot handle unseen states. Solution. Use a neural network to approximate QSA, leading to deep Q networks. Deep Q network formula derivation. Instead of maintaining a Q table, DQN learns the function QSA using deep learning. The loss function is as follows. Q policy is current Q network, predicts current Q values. Q target is target Q network, provides stable learning target. Theta is policy network weights. Theta minus is target network weights, periodically copied from policy network. Key features of DQN. 1. Experience replay. Stores past experiences in a buffer. Samples random mini batches during training. Breaks correlation in data. 2. Target network. Uses a separate target Q network with frozen parameters. Reduces training instability by updating every n steps. 3. Epsilon greedy policy. Balances exploration, random action, versus exploitation, choosing best action. Now we implement the Deep Q network code. DQN class. Replay buffer class. DQN agent class. testing the DeepQ network model.